You were saying in the book that you hypothesized that it could have been a light sail.
So the way I arrived at that suggestion was that to say, okay, there is data that the object was pushed away from the sun by a
Hmm.
force that declined inversely with distance squared, and there was no cometary tail. We didn't see any cometary evaporation. There were very tight limits put by the Spitzer Space Telescope on molecules or dust particles that evaporated from the object that can give it its push. And moreover, the force that was acting on it based on the data was smooth. It didn't, there weren't variations. The
Right.
object didn't change its spin period, the rotation period, as you would expect if the push was driven by evaporation of gas in jets, like the way you see it in comets. So at any event, I said, okay, what else can give it that push? And the only thing that came to my mind was the radiation pressure from the sun, the fact that the sun illuminates this object, and that can push it but for that to be effective, the object had to be very thin. So that led me to suggest maybe it's a very thin object like a sail. And we are currently developing light sails for propulsion. And the reason we do that is because this technology doesn't require for the spacecraft to carry the fuel with it.
Right.
It can therefore be pushed to very high speeds without carrying any fuel. And that's a possibility. But since then, since I wrote that scientific paper, that by the way was accepted for publication within a few days and received a lot of attention, since then, of course, I wrote my book, but I also came to realize that it may not be necessarily a light sail, because in 2020, in September 2020, that was 3 years after the Oumuamua was discovered,
Hmm.
there was another object discovered by the same telescope in Hawaii, Pan-STARRS, which exhibited an excess push away from the sun by reflecting sunlight and no cometary tail. And it was given the name 2020 SO. And the astronomers who discovered it within a few weeks realized that it actually came from Earth. It was a rocket booster from a 1966 launch as part of a
Hmm.
lunar lander mission. And so we know that we produced it. We know that it was artificial. We know that this rocket booster had thin walls, and that's why it was pushed by reflecting sunlight. But it was not designed to be a light sail. So it could be just a relic of something else, something that had thin walls. The main point of my proposal was that it could be artificial in origin because, a rock usually is not that thin.
Hmm.
Nature doesn't produce such things. And if it was a comet, we didn't see the evaporation of it. But since then, some mainstream astronomers who worked on rocks for decades argued, well, maybe it's a rock of a type that we've never seen before, like a hydrogen iceberg or a nitrogen iceberg, where we wouldn't see the cometary tail because it's transparent.
Right.
And there are problems with those suggestions. First of all, we never saw a hydrogen iceberg. We don't know if it's produced by nature. We never saw a nitrogen iceberg. But in the case of hydrogen, it evaporates very quickly. It wouldn't survive the journey in interstellar space. In the case of nitrogen, there is just not enough frozen nitrogen, solid nitrogen on the surface of planets like Pluto. We did the calculation with my students. So there are challenges, but also we've never seen those things. So you cannot argue with certainty that it
Hmm.
must be natural because it's a rock of a type that was never seen before. Because then you would resemble a cave dweller finding a cell phone and saying the cell phone is a rock of a type that I've never seen before. That obviously we need more data, and the only way to find it is to be open-minded.